Welcome to the California High School Exit Exam in Mathematics section of www.happynumbers.org. Today's lesson is going to be dealing with the strand which talks about algebra and functions, and the specific lesson is going to be talking about coordinate planes and ordered pairs, and I'll explain that to you as we go along. This is a representation of a coordinate plane, okay? It's a flat figure that is divided up into grids. And let's just take a look at, you'll notice here, the center point where these two dark lines intersect, that's called the origin, and that value of the origin is 0. And you'll notice we have an x-axis, or what is called a horizontal axis, an x-axis, and it starts at 0 and it goes in a positive direction to the right and negative direction to the left. That's the horizontal axis, that's this one. And we have a vertical axis, or a y-axis, which is perpendicular to the x-axis or horizontal axis. And it starts at 0 at the origin and goes in a positive direction up and in a negative direction down. And that is the y-axis. And this is what a coordinate plane looks like. And I know this may seem silly to you, but coordinate planes are extremely important, and they're in your life almost every day. First of all, the entire world is divided up into coordinates. In fact, in social studies or in science, if you've heard the terms lines of latitude and lines of longitude, those are lines that divide the entire world into coordinates. Actually, scientists have divided the entire universe into coordinates. So, if you drive a car, or if you know someone who drives a car who has one of those global positioning devices, one of those devices that you program in where you want to go, and then the machine will tell you turn left here, get on highway 70, drive 7 miles, etc. That is all done by coordinate geometry. Again, the world is divided into coordinates. The satellite reads your coordinates, where you are and where you're headed, the satellite up in the sky, and then it tells the computer software exactly what to tell you. Ships out at sea, the ocean, well, the entire world is, so the ocean is also, the oceans are divided into coordinates. That's how ships navigate, by coordinates. Planes, airplanes, flying from New York to San Francisco, they don't just fly from New York to San Francisco, they fly from New York to one coordinate and then another coordinate and another coordinate and eventually wind up in San Francisco. And space. Astronomers studying stars, the entire universe is divided into coordinates. So a basic understanding of coordinate geometry and what are called ordered pairs of numbers is somewhat important because it's in our lives all the time. So let's take a look at ordered pairs. Any point on this coordinate plane, any point in the world, any point in the universe, can be defined by a pair of numbers, by two numbers. And they're always written this way. The x value is first and the y value is second. Let me give you an example. Suppose this is the world. Just make believe. And here's a particular point in the world, and we want to find it. Well, if we know the ordered pair, 2, 3, and we know that x is 2 and y is 3, and both of these are positive, we start at the origin, and we move in a positive direction along the x, 1, 2, and then we move in a positive direction along the y, which would be going up, and that's 3, 1, 2, 3, and we've found that spot in the world, in the universe, doesn't matter. Let's do another one. This particular thing, this particular spot in the universe is called -5, 5. Well, the first number represents the x. So we have to move in a negative direction 5. 1, 2, 3, 4, 5. And the y value is positive, so we move up 5. So it'll be, we already have 1, 2, 3, 4, 5. So this value, right, this spot right here is 5, 5 in our plane right here, which we're making believe is the world or the universe. Let's look at example 3. Okay, here you're out in the woods and you're lost, but you have a coordinate map, and you call me, and I have the same coordinate map also. And I said, well, where are you? You say, well, I'm at 6, negative 4. Well, I know exactly how to find you then. I know that this first number is the x. So I move 6 along the x-axis, starting at 0, 1, and it's positive 2, 3, 4, 5, 6. And I know that the y value is negative 4. That means I'm going to go down 4. So that's 1, 2, 3, 4. And I've found you. Simple. Take a look at the last one. This is a little different, but I'm sure you'll get it. Here, the value of this, the name of this spot is negative 9, 0. So we have to move negative 9 along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. But y is 0, so we don't move anything on the y-axis. So that point right there is negative 9, 0. Good. Let's take a look here at how to locate. I'm going to give you some practice in locating points. Remember, you always start at the origin. First number is always the x value. Second number is always the y value. If they're positive, you move this way on the x and this way on the y. If they're negative, you move this way on the x and this way on the y. So, put your video or DVD or whatever you're working on, put it on in a second, put it on pause, and try and with your finger locate these points on this coordinate plane. Then turn it back on and we'll see how you did. Okay, go ahead. All right, well, let's see this one. 3, 4. Well, x is 3 and y is 4. They're both positive, so let's see where that point is. We start at 0. 1, 2, 3. 1, 2, 3, 4. So that point right there is point 3, 4. Now here we have negative 4, negative 3. So x is negative 4, y is negative 3. So we start at 0 and we move in a negative direction on the x-axis, 1, 2, 3, 4. And then we move down because y is negative 3, so we're going down 3, 1, 2, 3, and that's the point right there. Let's try this one. 5, 7. X is 5, positive. Y is 7, positive. So start at 0. 1, 2, 3, 4, 5. And positive 7. 1, 2, 3, 4, 5, 6, 7. So that is 5, 7. Last one. 0, 8. So x is 0. So we go to 0, but we don't move now. And then we go negative 8. 1, 2, 3, 4, 6, 7, 8. So that point is 0, negative 8. So you can locate any point on this coordinate plane or in the world or the universe by using these coordinate pairs of numbers. Now I'm going to show you some typical problems that you will get on the high school exit exam. You're going to get a question like this. The points 1, 1, 2, 3, 4, 3, and 5, 1 are the vertices of a polygon. What type of polygon is formed by these points? And then you have to select either a triangle, a trapezoid, a parallelogram, or a pentagon. So what this question is saying is there are 4 ordered pairs, and you're going to plot each of these ordered points, and then you're going to connect the numbers, and when you do that, what kind of figure will it be? Will it be a triangle, a trapezoid, a parallelogram, or a pentagon? Well, let's take a look here. We know what a triangle looks like. That's this. Now, this is a trapezoid. A trapezoid has two parallel lines. This line and this line are parallel, but this line and this line are not parallel. This is a pentagon. Pent means 5, pentagon, and it has 5 sides. And both of these are parallelograms. Parallelograms, this side and this side are parallel, this side and this side are parallel. This is a rectangle, pardon me, which is a parallelogram also, because these two sides are parallel and these two sides are parallel. All right. Oh, and by the way, the term vertices, right here, this word vertices, it means anywhere that two lines come together. That's a vertice, that's a vertice, that's a vertice. This is a vertice, this is a vertice, that is, this is this. Anywhere where two lines meet. This is a vertice right here where these two meet. This is a vertice right there. Okay, so we're going to plot these points. So let me get my line tool here. Okay, first point is 1, 1. Well, x is 1 and y is 1. They're both positive, so I move 1 on the x-axis, 1 on the y-axis, and I put that point there. Now this is 2, 3, both positive, so I move 1, 2 on the x-axis, 1, 2, 3 on the y-axis. Okay. Next one is 4, 3, and they're both positive, so I'm going to move 1, 2, 3, 4 on the x, 1, 2, 3 on the y, and the last one is 5, 1. So I'm going to start at 0, move 1, 2, 3, 4, 5, and up 1. And now I connect these. And what figure do I have? Well, you would pick choice B, a trapezoid. A trapezoid. Excellent. Excellent. Okay, now let's take a look at a different kind of problem that you'll get. They may show you a geometric shape on a graph. Let's suppose they show you this shape. We'll make a triangle here. Sorry for my sloppy drawing. Okay, they show you that shape. And they'll ask you to reflect the shape over either the x-axis or the y-axis. Well, all you have to do is think of the axis that they ask you to reflect as a mirror. Let me give you an example. Suppose they said they want you to reflect this figure over the y-axis. Well, this is the y-axis right here. So what they want us to do is draw this figure here like that. So all we did was flip the figure over onto the y-axis. Notice that there is this space here and this space here. That's why we have this space here and this space here. So you're just redrawing it over. And what they usually do in this kind of a problem is they'll give you this picture and say, if they say reflect it over the y-axis, you won't have to draw it. They'll give you 4 different pictures and you'll have to pick the one that shows this one reflected over the y-axis. Pardon me. Suppose they wanted you to reflect it over the x-axis. Well, you would just go like that, and like that, and like that. And there you have it reflected over the x-axis. Okay, that's pretty simple and straightforward, and you can be pretty sure you probably will get a problem like that. Let's take a look at a different one. You may get a problem like this. They're going to give you, let's say, we'll go up 1, 2, 3, 4, 5, and we'll go over 2. Okay, so they're going to give you something like this, And they're going to say, what are the coordinates of point A, which would be this point right here? What are the coordinates of point A if this figure were reflected over the x-axis? Okay, so the first thing we have to do is reflect that figure over the x-axis. So we went down 1, 2, 3, 4, 5. And so that's it reflected over the x-axis. And this is the point A here. This is our point A. Now they want to know what are the coordinates of point A when it's reflected. So we have to get the coordinates of this point right here. Well, the coordinates of this is, it's 1 over on the x-axis. So the coordinates would be 1, and then we count down the y-axis. 1, 2, 3, 4, 5, 6. So the coordinates of point A, of this point A, when this figure is reflected over on the x-axis, is 1, -6, because we just reflected that figure and we drew it right there. Well, that's it for coordinate geometry and the types of questions, and ordered pairs, and the types of questions that you will get dealing with ordered pairs on the high school exit exam. We will be doing another lesson on coordinate geometry where we're going to talk about lines and slopes, but that's a whole different thing. So, thank you very much for your attention, and see you next time.